We need to build social systems in order to understand complex systems, especially with the brain. So the nervous system, the human brain, is one of the most complex systems that we understand today. And we're still working to be able to do things like fix diseases such as schizophrenia, Alzheimer's disease, and we still are working to do things like try to augment it in cases of education or rehabilitation. But we run into the standard problem that we often like to study systems like this one dimension at a time, and in the nervous system, so many are interacting with each other that it's difficult. But we can build software to help us do this. The first thing that software has to do is help us visualize all that data. So when we're studying the nervous system, say looking at the brain of the fruit fly, we have data sets that are collected from dozens of different individuals that are looking at different individual modalities. In a picture like this, you're actually fusing together whole brain imaging, single cell imaging, gene expression data all into one picture. But if we really want to understand the complexity of the system deeply, we need to be able to interrogate it using modeling and simulation that's deeply tied into that data. The second thing our software needs to do is we need to be able to collaborate. These kinds of data are so complex that single individuals don't often understand all of it, so we have to build teams. These teams have to be able to combine together data from coordinate systems to build atlases. We have to be able to fit this data together through data transformations using the efforts of different research and analytics partners. And we need to be able to have user interfaces that can allow the user to essentially point and click directly on the question that they have in order to answer it. So we realize that the software that we have to build isn't just intended for a single user. In fact, this software needs to create a social system of interaction and interdisciplinary collaboration. That's a key principle for this software. The third thing that we have to have in our software is a good way to build it. And it turns out that software that has all these requirements can't just be built by any teams. So our teams have to be able to take advantage of state-of-the-art process control. We need to be able to use agile development loops. We need to keep in mind the best open source community standards as well as industry standards. The team actually has to have neuroscience data experience. Otherwise, you're going to essentially have the blind leading the blind, and that's also a tall requirement for software engineers to have neuroscience training. But lastly, our team has to also have full-stack software engineering experience. The kinds of systems that we need here are deeply client-server, they're extremely modular, they need to be maintained over long periods of time, and so these three things have to intersect in one software development team in order for us to be able to build this kind of software. So let's look at what kind of stuff we can create. So I mentioned the brain of the fruit fly. Let's take a look at some examples of what's possible. So in a visualization like this, you're actually fusing together data from hundreds of researchers that have been collected over thousands of hours in projects where literally hundreds of millions of dollars have gone into creating data like this. Normally, this data is essentially going to sit under the desk of the researcher and be lost and forgotten. But with environments like this, we've been able to expose this data now online, on the internet, this goes through the web browser, to essentially the entire world, to be able to create a social system of interdisciplinary research and investigation where we can query, we can ask complex questions of this data, and explore it much more deeply into the future. As I mentioned, we also want to be able to understand causal interactions. And in computational neuroscience, the state of the art for a long time has been models of ball and stick of this variety, like you see here, where you can sort of look at dozens of parameters at a time. But the game changer now is that we're able to take the kind of rich data sets that have been collected by experimentalists that have had all that investment and bring that into these environments so that we can actually now start to do modeling and simulation directly on the primary data that has been collected. And this is what we really think is new in this space and what's really going to unlock the potential for corporate R&D in the spaces of pharma and biotech, where we're going to have academic collaborations where we have the computational person and the experimental person sitting side by side, whether that's actually in the same room or across the world, because they're using environments that are fundamentally online, that are fundamentally collaborative. So with environments like this that allow us to visualize the data, that create the kinds of rich collaborations that are needed and that are built by software teams that have the right intersection of values, what we look forward to is a space where we're actually having software that creates a social system, but that social system is helping us unlock and unpack the true value of a complex system, even a system as complex as the brain. My name is Stephen Larson. This is all the product of a company that I'm the CEO of called Metacell. If you have any problems in this space, I'd be very interested to talk with you later on. Thank you very much.